high school calculus, calculation of area and volume. This video is the application of integral. We do solve some of area and volume calculation problem, and some of problem already listed in the previous video when you learned the integrals, but we kind of skipped around. Here we have a new video, so we can spend some time going into the details. Okay, the first one is find the area of 1/4 circle below. Okay, so we have to make it y equals fx to find the area below. Then 0 to a fx dx. So what is y equals fx? Is square root of a square minus x square. Okay, this form you can look up the integral table, but let's solve it directly. Okay, now we assign x is sine u, so dx become cos u du, right? So if we put the a in front, it's still unchanged. Then in this case, fx becomes square root of a square 1 minus sine square u. Okay, so this is gonna be cosine square u, so it's going to be a cos u. Okay, so dx is replaced by this and fx is replaced by this. So what we have here is the area is 0 to a. Now since we make this function conversion, 0 means u is 0, okay, and a means sine u is 1. Okay, so it's a pi over 2, right? And put this all together, so this is the integral we have to solve. Okay, now you know from trigonometric 2u minus 1. Okay, so this is the double frequency, right? We have to take integral from to here, but this 2u is going to be here. It's come back to 0. So integral of this is going to be 0. You get it? Okay, so this is going to be a square 1 over 2 cos 2u minus 1, right? Integral du. Now this we can forget about it, so it's going to be just simple u, a square u, and 0 to pi over 2, right? Okay, so what we get, so it's going to be a square pi over 4, so it's going to be 1/4 of circle, right? Okay, find the area between cos and sine function below. So again, we had to find y equals, right? And that's cos x minus sine x. right? So the area is 0 to quarter 4 because cosine sine cross at the quarter 4, and cos x minus sine x dx, right? So cos x, you take an integral, is going to be sine x, and the sine x, you take an integral negative cos x. Okay, so let's see. Sine, this value is square root of 2, right? And the cosine also square root of 2. So when you plug in this, it's 0. If you put that 0, wait a minute, let's see, this is plus, yeah, so plug in, it's going to be square root of 2 square, this is square root over 2, right? Because let's see, 45 degree, right? This pi over 4. This height, the ratio, isn't it? So is square root of 2, yeah, okay. So it's going to be square root of 2, is that correct? Okay, next one, volume. Now in this case, in order to simplify 3D integral, we consider this disk area S equals radius is z, so pi z square, right? And the volume for dy is going to be delta volume is going to be s d y. So volume is going to be 0 to a s dy, which is 0 to a pi z square dy. The z square is a square minus y square, so it's going to be 0 a pi a square minus y square dy, right? So again, what you do is a sine u equals y, so a cosine u du equals dy. So we plug in this one here, and here it's going to be pi a square 1 minus cosine square u equals pi a square sine square u, right? Oh, sorry, this is sine, so it's a cosine. Okay, so this is going to be since you change to this, when this is 0, it's 0. It's a it could be 1, so it could be pi over 2, right? And pi a square cosine square u cosine u du. Okay, so we have to do integral of cosine to the third. And using partial integral, we reduce down to cosine u, then solve it. Okay. Oh, here's the answer. Okay, so you get 2/3 pi a square, which is a half of pi a square, right? So half of a sphere, that's the volume. This is how you calculate the volume. Volume calculation, we use the same technique here. Y equals a h x, it's already given. Okay, so this is h, and we consider the disk. So delta v, let's do delta v equals y s dx, and what is s? Is pi a h x square, right? So v equals 0 to a pi a square h square x square dx. It's going to be 1/3 pi a square h, and pi square ah is the bottom area, so 1/3 bottom h. So this is 1/3 come from there. Okay, so length calculation. How do you get the length? We have to get the ds. The ds is d square is dy square plus dx square. So ds is square root of y prime derivative square for dy dx square plus 1 dx. So the length is going to be 0 to a ds is 0 to a dy dx square plus 1 dx. So what is the dy dx? You have to take a derivative, right? So if you take a derivative, implicit derivative, 2x plus 2y and y prime equals 0. So y prime is negative x over y, right? And y is square root of a square minus x square. So y prime is negative x a square minus x square. You plug in this one here. Okay, so you get the derivative of a square minus x square and x square dx. This integral you have to execute. Okay. Okay, so answer is a pi over 2. So it's a quarter of the circumference. Circumference is 2a pi, and the quarter is this. Got it? Okay. Surface calculation. What is the surface of the sphere? Okay. Again, we take dy here, but instead of disk, it's not volume, it's a surface. We take this area. This area is 2 pi z is circumference times dy is the ds. Okay, so the s equals 0 to a 2 pi z dy. And what is a z? Z equals square root of a square minus y square. So we plug that in, and we calculate that integral. Okay, then we get the half of the sphere. Okay, the same thing. Surface calculation. Now this one, in the previous video we explained how to do calculation of surface area. We cut this cone and spread, it become this area. So you don't have to use integral, but you can use integral the same way. We take this circumference of the circle and delta x. So circumference of the circle delta x, and integral total s is s x 0 to a. The same method, okay? And the sx equals 2 pi x delta x, right? Sx is 2 pi x times delta x is this the band surface. And you take an integral from 0 to a, and that's going to give a entire surface area. Okay, so it's quite time consuming, but you have to go step by step. Then you can prove all the formula you have for the 3D area, volume, whatever you like. Okay, thanks for listening for these videos, and I'll see you in the next video.